Okay, so here is the big idea of the day, is this right here. The simplest equivalent form of a radical, when there is no perfect square factors in the radicand. Remember, the radicand is what's under or inside the radical symbol, and that a factor just means it divides evenly into it. So our goal is going to be to simplify radicals that are not perfect squares. And what I mean is not like, you know, it's between 6 and 7, but come up with a radical form. So I'm going to do quite a few examples, but you need to have your list of perfect squares handy. So my list of perfect squares, remember, I can write a few down here. Whoops, I got to change my pen or it's not going to work. 1, 4, 9, 16, 25, 36, 49. So when I'm doing this, I'm going to see if I can find the perfect square root if it's possible. When I look at 45, there's no number times itself that's 45, so that's not a perfect square. I can't find it. So I'm going to look at my list, and I'm looking at numbers less than 45. So here, 45 is right around here. And that divide into 45 evenly with no remainder. 36 does not divide into it without a remainder. 25 does not divide in without a remainder. 16 does not, but 9 does. So I'm going to change 45 and say it's the same thing as the square root of 9, and it would be multiplied by the square root of 5, because 9 times 5 is 45. And then to simplify this into simplest form, I want the highest perfect square that goes into 49, which is 9, and I don't want to use 1. 1 is not helpful. And then I find the square root of 9, which we know is 3. And 3 square root of 5 is equivalent to 45, the square root of 45. They have the same decimal approximation. So our goal is to take this and clean it up and put it in this form, and that is needed for when you add radicals together, which you will have to do in algebra and a little bit in geometry. You'll have to know these two different forms back and forth. So in our next problem, we have 24. 24 is right around here, and we're looking for numbers that divide into 24 with no remainder. 16 will not, 9 will not, but 4 will. So the square root of 24 would be the same thing as the square root of 4 times the square root of 6, because 4 times 6 is 24. There are a lot of numbers that divide into 24, but they have to be from our list. So I always get kids that do like I did 8 and 3 or 12 and 2. One of the numbers has to be a perfect square. So that's why I use these numbers I wrote up in blue. The square root of 4 we know is 2, and we don't know the square root of 6, so this would be an equivalent form, and this is the simplest equivalent form. Now, when you get to 3, the first thing you have to do is change it, so it would be the square root of 27. All right, now the square root of 27 is nice, but it's not a perfect square. And I need to look at my list, numbers less than 27, that's where I start. What divides in? Nope, that would give you a remainder. And if you don't know if it divides in, use your calculator and do 27 divided by 25, and you'll get a decimal answer. 27 divided by 16, you'll get a decimal answer. 27 divided by 9, that will work. That will give you 3. We know the square root of 9, so this 27 to the 1/2 would be equivalent to 3 root 3, because the square root of 9 is 3. All right, here we have 20, the square root of 20, so we're going to go ahead and say that's the same thing as 20 to the 1/2. And looking at my list, numbers less than 20 would be here. 16 does not divide in without a remainder, nor does 9, but 4 will work there. So that will be the same thing as the square root of 4 times the square root of 5. I know the square root of 4 is 2, so this is going to be 2 root 5 for my answer. Okay, doing great. The square root of 72. Now this is an interesting one, because if you look at your list, and you start with numbers less than 72, there are a couple perfect squares that go into 72. You need to pick the highest one. So when I look at my list, 64 does not divide in evenly, 49 does not divide in evenly, but 36 does. So this would be 36 times 2. I know the square of 36 is 6, so this would be, in simplified form, 6 root 2. By the way, 9 does go into 72, and even 4 goes into 72, but they're not the best. You need to pick the highest one. Okay, so again, you have to pick numbers where one of them's a perfect square, and it's got to be the highest perfect square. In this one, we're going to change 96 to the 1/2 and make it the square root of 96. And then, you know, this is something maybe you use your calculator for because you're not all that familiar. And if I did numbers less than 96 that work, 81 does not go in evenly. Try 96 divided by 49. That does not go in evenly. Try 96 divided by, I did 64. Did I do 64? That doesn't go in evenly, but I believe it is 36. So this would be, whoops, I just did it wrong. 36, whoops, 96 divided by 36. Nope, 36 doesn't work either. So, see, you gotta just check it out. Try 96 divided by 16. And that's the one that works. So I get 16 and the square root of 6. I know the square of 16 is 4, so that would be 4 root 6. All right, we'll just do a few more examples after this.